When we talk about the bash shell, basic scripting is one of the most common topics that comes to mind. In this session, we'll look at creating a basic shell script and some of the things that can impact running the script. Let's start with the basics. Create a file called my_first_script.sh in your home directory. Assign the file execute permissions. Now reopen the file and type #bang/bin/bash at the top. This instructs the script what shell to run under. This is important because your script can be made to run under a variety of shells. The path after the #bang is the path to the actual shell on your system. So if this is located in a different directory, you'll have to give it the appropriate path. A basic shell script is nothing mystical. It's simply a file that has one or more shell commands to run. Let's start with just displaying current working directory contents with ls. Save the file and run it. To run it, you need to either use bash space the name of the file, my_first_script.sh, or put a // at the beginning of the file name to do the same thing, indicating that you want to run the file that's in the current directory. Either will do the same thing, so you choose. You should have output that was what you expected to see from ls when this is done running. Back to the shell. Let's add a change directory command above the ls that will move us to our home downloads directory. Now save and run the script. Does it give the ls of the downloads directory? It should. Okay, now run pwd. Did our current working directory get changed? No. The reason is that the script runs in its own shell. It is not modifying our current shell. This will be really important as we move into more complicated shell scripts later. Now let's see how to add comments to the script. Any line that begins with a # will become a comment, a non-executing portion of the file. Add #changes directories to the line above the cd command, and add #runs the ls command over the ls line. Return to the script and ensure it still works. Testing early and testing often is a good idea. If you do too many things in a script without testing it, it can become really difficult to determine what was wrong. Now let's run our shell script in debug mode. You can do this interactively by using bash-x when you run your script. You can also alternatively add it to the script by adding the line set-x to the top of the script. This variation offers a way to debug only part of a script, but that is not covered here. For now, let's run the bash-x method to debug on our script. Look at the output and notice that the lines with the plus at the beginning are the lines displaying the command that is running, followed by the output for that command. Notice that I had to scroll up just a little bit because I had long output to get to those plus lines. Okay, now we know some basics about creating and running shell scripts. Now let's consider factors that may impact the shell script. The first thing is the type of shell the script is getting called from. There are different types of shell states, as I'll call them. A shell can be interactive or non-interactive. Technically, there are more types of interactive, but they are not tremendously interesting and are rather tedious to get into the details of them. Generally, you want to know if your script is interactive or not for two main reasons. First, it determines which files are loaded at startup, and secondly, it will make a difference if your script can ask the user questions, interact with them. If your script is going to ask a question of a user in a non-interactive script, how will it get the answer? If it can't get the answer, then it will just hang forever waiting for a response. This is the case when you run a script from an automated process like a cron job. Cron is a utility that automatically runs at a custom defined time. This is machine controlled and not initiated from an interactive shell where there's a person logged in. Let's have our script prompt the user for their name and then repeat it back to them. Add an echo line with how you want to prompt the user. Then, the next line, type read name. To use read to take the input and create a variable called name. Run the script and enter your name when prompted. Everything should work out okay. But think about if there was no interactive shell to complete the request. It would just hang. When running a script, it is common to want to write your standard error to somewhere other than the screen. To do this, type to redirect file name. The 2 is the identifier for standard error. The rest is redirect and the file name you are creating. Run our script with the command /my_first_script.sh space 2 redirect error.txt and then check the error file. It should be empty because there was no error. Now rerun the command with an incorrectly spelled script name and recheck the log. Now you should have an error in the log file.